Hello and welcome back to Finance World. In today's video we are going to continue with the topic of geometry and we are going to explore how to derive equations of a straight line. Okay, we are going to first present to you the 5 axioms postulated for Euclidean geometry again. They are to draw a straight line from any point to any other point, to produce and extend a finite straight line continuously in a straight line, to describe a circle with any center and any radius, and that all right angles are equal to one another, and finally the parallel lines theorem. And in this video we are going to explore the first 2 axioms in more detail. So let us recap what coordinate geometry is. It is a point in Euclidean space of an xy plane and has coordinates x and y. That is, movement along a horizontal x-axis and along the vertical y-axis. Okay, and that constructs our xy plane, as this is shown in this little bit of graph paper. Okay, now let's suppose we have any 2 points plotted on this xy plane. We are actually able to draw a straight line between the 2 points. Now here we are given a point -2 and 0 and 1.5, and they are now plotted on that bit of graph paper. We drew a straight line and extended it beyond the 2 points, and we could actually derive the equation of y equals a half x plus 1. Now this line shows that for any coordinate that sits on this line must abide by this rule. So how do we figure that out? First, let's choose any arbitrary x value and put it into that equation to find our y value. Let's suppose we have x is equal to 0. That means your y value is equal to a half multiplied by 0 plus 1. So y is equal to 1. That means the coordinates of 0, 1 will lie on this straight line. And that is actually the y-intercept if you look at it closely there. Okay, so how did we actually derive the equation of y equals a half x plus 1? First of all, we have to derive the gradient of this straight line. Okay, with those 2 points, -2, 0 and 1.5, we have given enough information to find this gradient. So you have plotted on a bit of graph paper just the 2 points to start with, and what we're going to call the gradient is actually going to be the difference in the absolute height between the 2 points divided by the absolute width between the 2 points. That means the height is 1.5 minus 0, that's the absolute height, and the width is 1 minus -2, which is 3. Note that because I took the coordinates of 1.5 to be the leading numbers in the subtraction, I have to do that the same for both the y values and the x values. Okay? That means we have the gradient of 1.5 divided by 3, that is equal to a half. Okay, that means we've gotten the gradient which is equal to a half. Now let us label the points -2, 0 as the coordinates of x1, y1, and we refer to that as point 1. And we have the coordinates of 1.5 as x2, y2, and that is 0.2, say. Now given this information, we're able to derive a general formula to find the gradient. This is of the form y2 minus y1 is equal to the gradient multiplied by x2 minus x1. Note that I said when you take one of the coordinates to be the leading number in your y values, that has to be the same for the x values. Now that doesn't look so familiar, so if you do a little bit of algebra, you can rearrange it so you can see that the gradient m is in fact the difference between the y values divided by the difference between the x values. Okay, so m is the gradient of the straight line. Some people like to call it the slope, but throughout this video and throughout my course, I will refer this to the gradient unless stated or otherwise. So now how do we derive the equation of a straight line? Now I told you that the coordinates must lie on that straight line and abide by that straight line. That means if you have any arbitrary coordinate point, you can actually find the equation of a straight line. You can find it from using this formula. Luckily, we have 2 points, so we can prove if this is the case. Okay, so xn and yn are just the points of any coordinates, and we're going to use both the coordinates we are given one at a time to check that we end up with y is equal to a half x plus 1. So firstly, let's try using the first coordinate point, which is -2 and 0, and we substitute that plus the gradient m equals a half into that formula. You have y minus 0 is equal to a half multiplied by x minus -2, which is y is equal to a half multiplied by x plus 2. Remember, when you subtract a negative number, you add the number. Let's now multiply out the brackets, so you actually indeed get y is equal to a half x plus 1, which is exactly what we had a few slides earlier. Now let's check it using the other coordinate point 1, 1.5, and the same gradient m is equal to a half. You now have to plug those numbers in, so you have y minus 1.5 is equal to a half multiplied by x minus 1. If we multiply out the brackets and then add 1.5 to both sides, we end up with y is equal to a half x minus a half plus 1.5. Collecting the constant terms together, you end up with y is equal to a half x plus 1. So we've now just shown that both of our coordinate points lie on that straight line of y is equal to a half x plus 1, and we derived this equation y equals a half x plus 1 from first principles. So now you look at it, it should be of a familiar form of y is equal to mx plus c, where m is the gradient of the line and 0, c would be the coordinates of the intercept on the y-axis. Now what does this actually mean in plain English? So m is the slope, as the people would say, a slope, and I call it mathematically is the gradient of that line. C is just where that line crosses the vertical y-axis, and in mathematical language it's called the intercept. Now note that if you have any equation with a single y to the power of 1, or any quantity of y, and if you have any quantity of x to the power of 1, and you rearrange it into this form, y equals mx plus c, you'll find that c is always going to be the intercept on that vertical y-axis. Now let me demonstrate to you with a little simple animation that when you're given any two coordinate points, you can actually draw a straight line between the 2 points and extend it out, and also derive the equation for this straight line. Okay, so we've got a little bit more to go on geometry. The next video I'll introduce quadratic equations and what do they look like when you plot them. We'll then look at angles and trigonometry, so we'll explore the third axiom of Euclidean geometry. Then we'll have a look at calculus and derive it from first principles, and also look at drawing tangents to these graphs that we are plotting, and then deriving the equations for those tangents. Once that is being visited, we will then look back to algebra again. We'll start solving some more simultaneous equations. This time we'll solve quadratic equations along with linear equations paired together, and then we will explore more special cases of quadratic equations. So if you like this content, please like and subscribe, and leave a comment down below on any of the content that you're unsure of within this video, and we can discuss this further. And then most importantly, stay safe and peace out.